Okay, today I'm working on this Yamaha amplifier. I've taken the board out already, so I'm not going to power it up. But basically the fault is it's completely dead when you press the power button, there's no activity. So what I did is I traced the fault down to this board. Pretty common problem with these is that capacitor there failing. Now this capacitor here powers this D-type flip-flop, which powers this MOSFET, which turns on this transformer through this bridge rectifier. It's a convoluted circuit. Essentially it's a standby power supply. It switches on and off a couple times a second to save power. Because without it this thing would use 3 watts, and with it uses about 0.3 watts. One could argue that all this excessive circuitry to save 2.7 watts, averaged over a unit's lifetime of maybe 10,000 hours, is hardly worth the effort, but regardless. It's mandated by EU requirements. So what I'm going to do is I'm going to place this capacitor. For this repair I am using these 22 nanofarad 1 kV capacitors. The original is only 630 volt rated, likely the cause of the fault because mains transients here can exceed 600 volts regularly. Basically this is a capacitive voltage dropper. It's a bit complicated to explain, but essentially it drops the voltage, and what happens to it is this capacitance falls over time. The voltage it produces for this D-type drops, and the error detect circuit locks out the processor. Eventually also the 10 volt standby this produces will also fail. But usually you get lockout. Now sometimes you get this fault, the amplifier will turn on once in a while when you're lucky, or it will switch on once it's cold, or it will switch off once it gets warm. Can be this fault. Previous video I have done a temperature sensitive analysis of this. I tried this on this one, it did not work, so this was probably a little past that. So I'll replace that and we'll see how it goes. Okay, moment of truth. Oh, look at that. Pass protection, that's the relays clicking. So this amplifier is fixed. We'll have to hear it purr later. I'll hook up some speakers. Anyway, I removed this capacitor. So let's test. Okay, so I'm going to set the multimeter to capacitance mode. And then let's just probe the capacitor. And you can see the reading on the meter, it might be hard, it's 6 nanofarads. So let's test a 22 nanofarad capacitor, the one I replaced it with. You can see 23 nanofarads, close enough. So this 22 nanofarad capacitor is measuring 6 nanofarads, and that's why the amplifier wasn't working, because when that capacitance drops, the voltage supplied to the standby circuit drops out. Okay, I'm going to now measure the supply voltage to this standby circuit, and you can see me at 7.62 volts. I didn't record this, but I measured it before. What I was getting was between 1 and 3 volts, and I'm measuring across on this board capacitor C3016. Yes, C3016. Which is a capacitor for decoupling the supply from the D-type flip-flop. So what's happening is that voltage there eventually drops out, but before it drops out, what you tend to get is about 5 volts or so on that. The D-type can quite happily work that. It works to about 3 volts. It works down to about 3 volts, but there's a little error detect circuit, 6.8 volt Zener and optocoupler in series, which will drop out at approximately 7 volts. So basically as soon as that voltage starts dropping out, the error detect will tell the processor there's a problem. Now I think this wasn't really intended originally as an error detect. From the circuit's design, I'll try and link to a copy of the service manual, but from the circuit's design, it looks to be an AC detect, so when you pull the power from the amp, it clicks off immediately. And there's a good reason for this, because if you leave the amplifier running without AC power, you've got two large capacitors on the board, and they'll slowly discharge and the audio will start distorting as the rails collapse, which will make for an unpleasant sound as it switches off.